Hey guys, welcome back. We are right now with the topic of isotopes. It's a very, very important topic. Let me inform you very clearly. Examiner is asking, define isotopes. Sometimes this definition can be of 2 marks. Yes, can be of 2 marks, seriously. And sometimes this such type of very, very easy definitions can be even asked in AS level as well. So please pay perfect attention to this topic. This topic will be carried on in AS level as well. Well, over there we will teach you some more details related to the isotopes. Here right now we are going to discuss isotopes in the details required regarding 5070 and 0620. Point number one is this, that what is the definition of isotopes? Okay. So atoms of, let me make it more, atoms of same element having same proton number but different nucleon number due to difference in the number of neutrons. So you can keep this information in your mind very clearly. Neutrons are not matching. Okay, neutrons not matching. Now the point is this, that how it is possible that neutrons are not matching. So what is matching? Electrons are same. Electrons and protons are same. Okay, but neutrons are not matching. We are going to implement this on the we are going to implement this definition. We are going to implement this idea on different examples. Let me turn the page. So number one example of your syllabus is isotopes of hydrogen. Okay, so basically there are three isotopes of hydrogen. Number one is called protium. Yes, different name. Number two is called deuterium. And number three is tritium. Okay, and then what is the symbol for this? It is 1H1, it is 1H2, it is 1H3. Yes, okay. And then what is the electron number in the first one? It is 1, 1, 1. What is the proton number in the first one? It is 1, 1, 1. Oh, so what is the neutron number here? It is 1 minus 1 is equal to 0. Yes. And then 2 minus 1 is equal to 1. Yes. And then 3 minus 1 is equal to 2. We have a very clear evidence that all of these three have different number of neutrons. Okay, here I have mentioned neutrons in the last column. Okay. So protium is the hydrogen which is mentioned in the periodic table as well. Where is 1H2? Where is 1H3? Why we are writing 1H1 in the periodic table? Why 1H2, 1H3 have no representation in the periodic table? These all mysteries are going to be unlocked very shortly, either in this lecture or in the coming lecture. All right. So please, this is the basic concept which I have told you till now, that what is the definition of an isotope, what is matching, what is not matching, and the examples of the isotopes from hydrogen. So how many isotopes of hydrogen are there in total? These are three hydrogens of isotopes in total. Some more information which I would like to inform you regarding isotopes of hydrogen is that deuterium is basically called heavy hydrogen. Deuterium is heavy hydrogen. Okay, whereas tritium is radioactive isotope. All right. And what is radioactive isotope? Emitting radiations. Okay. In which form they are emitting radiations? In the form of energy. So you must have this basic knowledge in your mind that radioactive isotopes are one of the way to treat cancer and other diseases, etc. Okay. So right now, deuterium is a heavy hydrogen, and where it is used, I'm going to tell it to you as well. I'm changing the board right now. So right now, for example, just consider this is the formula of water. We know this thing that oxygen has a mass of 16, and how we know this is the mass of 16? From the periodic table we know the mass of oxygen is 16. Okay, then we can say this thing that, for example, if we are making hydrogen from protium. Okay, if we are taking hydrogen from protium, so what will be the mass of water? It will be 1 for 1 protium, and the other hydrogen has also a mass of 1, whereas oxygen has a mass of 16. So the total mass of water will become 18 by using hydrogens from protium. But if we are using hydrogens from deuterium, what will be the mass? Deuterium, you can see deuterium. Okay, here we are going to use the mass of deuterium. We have seen on the previous board that the mass of deuterium is 2. This is the mass number at the top here. This is the mass number at the top here. And this is the mass number at the top here. Okay. So for deuterium, what will be the mass? It will be 2 plus 2 plus 16, because we can see that hydrogens are for 2 times in 1 molecule of water. So what is the formula of water? H2O. What is the formula of one molecule of water? H2O. It means that we have to consider hydrogen for 2 times. When it is protium, we are considering it 1 plus 1 plus 16. But when it is deuterium, we are considering it 2 plus 2 plus 16. So the total mass of water will become 20 in that case. Okay. And that water which is formed by use of deuterium is called heavy water, and it is used as a coolant. Where it is used as a coolant in nuclear reactor. Yes, we know now this thing. It's a common sense type of thing nowadays, that a student should know this thing, that nuclear reactor is a place where nuclear reactions are happening, and they are definitely emitting lots of heat energy. To cool down that nuclear reactor setup, we are using a specific type of water which is called as heavy water, and it is formed by use of deuterium as a hydrogen. Okay, coolant in nuclear reactor. Okay, then there is a third one which is called as tritium. Okay. Okay, bache. So this is now tritium. So for example, this is H2O, and we are writing here the masses from hydrogens of tritium. Okay. So one hydrogen has a mass of 3, and other hydrogen has a mass of 3, whereas oxygen has a mass of 16. Look, oxygen, we are always taking 16, 16, 16 in all the three. Now, what is the mass of water here? It will become the total 22. So we can see this thing very clearly, that all three waters have a different type of mass by using protium, deuterium, or tritium. Okay, so this is the information related to hydrogen isotopes, and they are making water of different masses. Okay, now I am giving you another example of isotopes. And what is that example? It is isotopes of chlorine. This is also part of your syllabus. I can tell you one more thing before teaching you the isotopes of chlorine, that there are many other isotopes of different elements. Some of the isotopes are already discovered. Some of the isotopes scientists are preparing artificially, and some of the isotopes you will see in many of the books. Might be examiner is mentioning some other isotope, but right now let me inform you very clearly, the isotopes of your syllabus are only isotopes of hydrogen and chlorine. Okay, I mean to say you should know the details of hydrogen and chlorine only. But if examiner is asking oxygen has this isotope, zinc has this isotope, uranium has this isotope, etc., etc., then you people should have an idea that other elements can have isotopes. Some of them have been taught to us and some of them are not. Okay, so this should be very, very clear. So in the next class, inshallah, I'm going to discuss the isotopes of chlorine and further aspects related to isotopes. Thank you very much. Take care of yourself.